Hey guys, welcome to our first MathsArc video, and today I'm going to show you how to complete the square. So when you complete the square, you're taking a quadratic of the form y equals ax squared plus bx plus c, and you're rearranging it into the form y equals ax plus p squared plus q. And the trick that's worth remembering is, ignoring a and c for a moment, we can rewrite x squared plus bx as x plus b over 2 squared minus b over 2 squared. And as you can see, that will give you the x plus p squared that we want over here on the right hand side in the completed the square form. Before I show you this trick in an example, let's just prove to ourselves that this is true. So we could expand the right hand side, and hopefully we would end up with x squared plus bx. But we also notice that the right hand side is a difference of two squares. And whenever you have a difference of two squares, say u squared minus v squared, it can be rewritten as u plus v times u minus v. So in this case, we can rewrite the right hand side as x plus b over 2 plus b over 2 times x plus b over 2 minus b over 2. And so in the left bracket we get x plus b, and in the right bracket these two will cancel, so we end up with x. And expanding we get x squared plus bx, which is what we wanted to show. So with that said, let's move on to an example. But first let me quickly write down what we've just shown at the top. So we have x squared plus bx being equal to x plus b over 2 squared minus b over 2 squared. So let's say we have a quadratic y equals 3x squared plus 6x plus 1, and we want to complete the square on this quadratic. So the first thing we have to do is we have to factorize the coefficient of x squared, or the number in front of x squared, from the first two terms of the equation. So we're factorizing 3 from the x squared term and the x term of this equation. So we end up with 3x squared plus 2x, and we leave the 1 alone at the end. At this point we can now use the trick that we have at the top. So we have x squared plus bx being equal to x plus b over 2 squared minus b over 2 squared. So if we compare on the left here, we see that b is equal to 2, and therefore b over 2 is equal to 1. So that means that x squared plus 2x is equal to x plus 1 squared minus 1 squared, or just x plus 1 squared minus 1. So now that we have this equivalence, we can actually just replace the x squared plus 2x with x plus 1 squared minus 1. And being careful with brackets, we end up with 3 x plus 1 squared minus 1, close brackets, plus 1 at the end. Now if we distribute the 3, we end up with 3 x plus 1 squared minus 3 times 1, add 1, and that will give us 3x plus 1 squared minus 2. And that's the final result that is now in the completed the square form. So now that we have completed the square, there are a couple of things that we can do with our equation. And the first thing we can do is set y equal to 0 and solve for x. And that would give us the roots of the equation. So let's do that first. 3x plus 1 squared minus 2 is equal to 0. So if we add 2 to both sides, then that will give us 3x plus 1 squared is equal to 2. So now we should divide both sides by 3. So now we have x plus 1 squared is equal to 2 over 3. So if we square root both the left and the right hand side, then on the left the square will cancel with the square root, and on the right we have to remember both the positive and negative square root of 2 over 3. So now we have x plus 1 is equal to plus or minus 2 over 3. So if we take 1 from both sides, then we end up with our two solutions for x, which are minus 1 plus or minus the square root of 2 over 3. And although we usually don't like fractions inside of surds, we won't worry about it for now because surds aren't the topic of this video. A second thing that we can do once we've completed the square is read off the turning point of, or I should say the coordinates of the turning point of this equation just at a glance, and I can see that they are minus 1, minus 2. The x coordinate of the turning point is always the negative of this value inside of the brackets, and the y coordinate is always the value outside of the brackets over here. So let's think about why this is the case. If we look at the coefficient of x squared, we see that it's 3, which is a positive number, and so we know we're dealing with a happy parabola. So the shape of our graph is going to look like this, which tells us that the turning point we're looking for is a minimum point. So how do we minimize the value of 3x plus 1 squared minus 2? Well, we focus our attention on x plus 1 squared, and we would note that this cannot be negative because it's a squared term, and so the minimum value it can take is 0. And that tells us the minimum value y can take is 3 times 0 minus 2. So the minimum value for y is minus 2. And when is x plus 1 squared 0? It's 0 when x is minus 1. So that will give us the coordinates of our turning point. And so just to recap, the x coordinate is given by the negative of the value inside of the brackets, and the y coordinate of the turning point is given by the number outside of the brackets over here. Here we've got a question from an Edexcel A-level past paper, and the question involves completing the square, so I thought we'd take a look at it. So we have a function f of x that's equal to x squared minus 10x add 23. And in part A we're told to express f of x in the form x plus a squared plus b, where a and b are constants to be found. So in other words, complete the square on f of x. So since we see that the coefficient of x squared is 1, we don't need to factorize anything out of the first two terms, so we can go straight in and use the trick that we saw earlier. X squared plus bx is equal to x plus b over 2 squared minus b over 2 squared. And comparing, we see that b has to be minus 10, and that b over 2 is therefore minus 5. So we can plug that into these values and we get x squared minus 10x equals x minus 5 squared minus 5 squared, or x minus 5 squared minus 25. But we're not done yet. We have to replace x squared minus 10x with our new form. So if we do that now, we get f of x is equal to x minus 5 squared minus 25 add 23, and that will give us x minus 5 squared minus 2. So that's the first part done. Let's move on to part B. Hence or otherwise find the exact solutions to the equation x squared minus 10x plus 23 equals 0. So we've just shown that x squared minus 10x add 23 is equal to x minus 5 squared minus 2. So therefore, if the left-hand side is equal to 0, which is what we're told in the question, then the right-hand side is also equal to 0. So we can set that equal to 0 as well. And now we can rearrange and solve for x. So we get x minus 5 squared is equal to 2. X minus 5 is equal to plus or minus the square root of 2. And therefore x equals 5 plus or minus the square root of 2. I'm going to leave part C for you guys to do on your own. So give it a go and post your answers in the comments section, along with any questions that you have. But that's all for now, and I'll see you in the next video.